Hello, I want to talk about optical communication and answer these four questions. For first question, how optical communication capacity has grown in the past 20 years, how will it grow in the future? As society has grown more complex, they need to expand information transmission capacity. So they made optical fiber. Optical fiber discovery was a revolution in the global communication industry. For the first time in the early 1980s, optical fiber was installed by telephone companies. Optical fiber can carry vast amount of information and light signals over long distance. But for increasing network capacity in the future, we need to improve fibers, better electronics, and optical components to improve signal quality and efficiency. For second question, I want to discuss about three photonic components: LED, laser diode, and photodetector. First of all, I'm going to talk about laser diode. As you can see, this is the whole structure of laser diode. In laser diode, there are three phenomena by which an atom can emit light energy. These are absorption, spontaneous emission, and simulated emission. This is the general structure of this process: absorption, spontaneous emission, and stimulated emission. Laser diode is made up of two layers of semiconductor, p-type and n-type. Layers of semiconductor are made of gallium arsenide doped with different material. Laser diode is forward biased by an external voltage. Then electron can move through the junction and recombination occur. As forward current increase, more electron enter the depletion region and cause more photon to be emitted. The other one is photodetector. There are different types of photodiode: pin photodiode, avalanche photodiode, and PN junction diode. Photodiode is PN junction or pin structure. When photon has sufficient energy, strikes the, as you can see this, strikes the diode, then excites an electron, thereby creating a free electron and hole. So by applying bias, hole moves toward the anode and electron moves toward the cathode and photocurrent is produced. This is the depletion region that hole and electron can move through it. The last one is LED. LED also is a PN junction diode. This is the structure of LED. Emits light when an electric current passes through it in the forward direction. In LED also recombination occur. So electron from the N side and the hole from the P side, this is N side and this is P side, combine together and give the energy in the form of heat and light. LED also is made of semiconductor, but consider that the significant difference between LED and laser diode lies in the working principle. LED emits light as a consequence of charge carriers recombination across p-n junction, while laser emits light as a result of photons striking the atom and compels them to release the similar photon. For third question, is there any limit in optical communication capacity and how we can overcome it? Yes, there is limitation in optical communication, especially for line distance. We have attenuation and dispersion. But over the last decade, attenuation and dispersion of single-mode fiber and multi-mode fiber have been reduced. This is attenuation, as you can see, and this is dispersion. The other one is optical fiber nonlinearities can be significantly reduced by increasing the effective mode field area. This can allow system designer to increase launch power from more transmission distance or higher bitrate signal or both. The other one is fiber fuse. This is fiber fuse. Fiber fuse is a phenomenon that results in a specific type of catastrophe, destruction of optical fiber core due to applying high optical power that we should control these amounts of power. And the last one is signal loss due to more band over line distance that we should avoid more band to decrease the signal loss. For the last questions, who are the leaders in developing future optical communication? I only focus on North America and USA. As you can see, there are different research centers and institutes in North America and USA. In Canada, such as Communication Research Center, Canadian Photonic Fabrication Center, Center of Excellence in Next Generation Network, or the other research center are working on fiber optics and telecommunication to improve it. Also in USA, there is Corning company. Corning's leadership in the optical communication industry. It takes many forms: innovative products, award-winning solution, and unique co-innovation approach with other leaders in the field. All of these companies are working on improving a better optical communication across the world. They improving optical fiber and extreme density cable for communication. And also in Europe and Asia, there are different research centers and institutes which are leader in Europe or Asia, especially in Asia. South Korea, China, and Japan are working on communication to improve it in the future. Thank you for listening.